Hello students, I am Dr. B.K. Singh, Professor of Civil Engineering at Ajay Kumar Garg Engineering College, Ghaziabad. So, today we will be discussing unit number 2, lecture number 4, Supplementary Cementitious Material Part 4. So, in this particular lecture, I will be discussing you GGBF and metakaolin. So, I will be discussing GGBF, granulated grounded blast furnace slag, in details and brief in metakaolin. So, if you see here supplementary cementing material. So, you can see the color of supplementary material. If you see from left to right, so this is a fly ash class C, which is having a cementing properties as well as pozzolanic properties. Then we have metakaolin here, this is a whitish in color. Then we have silica film, that is little dark here. Then we have fly ash class F type, that is not a hydraulic in nature, but it is having a totally pozzolanic properties. And then we have slag cement or you can say GGBF, which is also in whitish color, and we have calcined shell. So, what is slag? So, slag is a non-metallic byproduct consisting essentially of glass containing calcium silicates and calcium aluminates of lime and other bases developed in a molten condition simultaneously with pig iron in a blast furnace slag or electric pig iron furnace. So, here you can see here this is the diagram of schematic diagram of symbolic diagram of blast furnace. Okay. So, in this blast furnace this one we are getting as a byproduct. So, in this one we are putting the iron ore, then we are putting the limestone and coke, and we get up to the temperature of about 1500 degrees centigrade. So, inside temperature may be 1700 degrees centigrade, but for fusion we need at least 1500 degrees centigrade, and bottom density will be more. So, molten iron will be there, pig iron, and on the top we have a slag, So, that slag can be taken out from here, and this is a waste material, this is a byproduct in production of iron and steel, that is in production of iron and steel. So, here we have to get the granulated slag. So, how we will get the granulated slag? So, granulated slag you can obtain by further processing the molten slag by rapidly chilling or quenching it with water or steam and air. So, that is very, very important, otherwise you will not get the glassy phase. If you want to get the glassy glass, in that case it should be you should get the granulated type. So, their size will be about 0.4 mm, just like a sand, around 4 mm average size will be there. Okay. So, that you have to take out from here and you have to chill it suddenly. Okay. So, here we have seen here. So, here this should have a temperature of this temperature. So, here fusion temperature should be around 1500 degrees centigrade, then only you can able to get that proper slag. If you are not getting those temperature, maintaining those temperature, then you will not get the granulated condition, and that must be quenched or rapidly chilled either with water or steam and air. So, that is the process or getting the granulated slag. So, blast furnace slag about 20% mass of the iron, you can get blast furnace slag. And granulated blast furnace slag, if the molten slag, a byproduct of iron and steel making, is cooled and solidified by rapid water quenching to a glassy state, to a, that is important, glassy state, little or no crystallization. So, crystallization should not take place. This process result in the formation of sand size fragments like clinker material. Okay. So, this clinker material is having a size of about 0.4 mm, 0.4 mm. Okay. So, then we have to grind it, otherwise their surface area is around 500 centimeter square per gram. So, that much will not be able to react properly. So, you have to grind it. So, when ground to very fine cement size particles or even more than that. So, ground granulated blast furnace slag GGBF phase has cementitious properties. Okay. So, it will have the cementitious properties as well as pozzolanic properties both. Okay. So, here grinding is important. So, because if you do not grind it properly, then it will, you will not be able to achieve proper result. Okay. So, GGBF is a suitable partial replacement or additive to Portland cement. Okay. So, either you can intergrind with cement, mix with the cement, or you can use as a admixture. So, up to 70%, this is the latest recommendation here if you see of Bureau of Indian Standard. So, they permit you can replace it up to 70%. Okay. Earlier it was less, but now due to the more research and result, they permit now you can replace this in the range of up to 70%. Okay. So, if you see here, three things you can do. Either you can take the slag, slag means granulated slag, you can take a granulated slag. Granulated slag you can take, plus clinker you can take from the cement clinker, which is having 4 compounds like C3S, C2S, C3 and C4A, and you can take gypsum retarder, and you can be intergrounding in ball mill and tube mill. Okay. So, this is one of the condition you can do. So, in this case what will happen, you will reach the similar grinding, because if you see the OPC cement, this is about 2250 centimeter square per gram a specific surface area. Okay. So, this you can grind little higher, around 3000, or ground each component separately and blend well and then use as a slag cement. So, that is also possible. In that case you can save more energy, because if you are grinding slag, clinker, gypsum, in that case energy requirement is more. If you are grinding the component granulated slag separately and clinker and gypsum separately and mixing each other. Okay. So, that you can save more energy. So, that is also one of the possibility. Another condition is you just separately ground granulated slag and you use at the time of mixing. So, you take this OPC separately and GG granulated grounded blast furnace slag separately in some amount percentage permitted per percentage, and you can ground. So, 3 possibility is there. Okay. So, that is possible, you can use the in 3 ways. So, this is the thing. So, if you see the approximate oxide composition of cement clinker, BFS and fly ash, you can see here in cement COA percentage is around 60 to 67, blast furnace slag you can get around 30 to 45, but fly ash it is little bit is there around 1 to 3%. If you see the SiO2, so this content is around 70 to 25 in cement clinker and around 30 to 38 in blast furnace slag, and in fly ash this component very high around 35 to 60. If you consider the Al2O3, this component is 3 to 8%. So, this component we are adding in cement to reduce their fusion temperature. Okay. And blast furnace slag naturally you will get around 15 to 25%, and even in fly ash also you can get 10 to 30%. Okay. So, this thing is responsible for pozzolanic action. Okay. So, this is responsible for pozzolanic action, and this is going to give you cementing property. This is going to give you directly cementing property. And similarly, you have MgO is there, MnO2 is there, glass phase if you find, so you will get 85 to 98% material is in glassy phase. This is a glassy not crystalline, and if you see the fly ash also you can get around 20 to 30% in glass condition, which is very highly reactive. Okay. And if you see the specific gravity of cement is around 3.15, and blast furnace slag is little less 2.9, and if you see the fly ash it is ranging around 2.1 to 2.6. So, these are the approximate oxide composition and some physical properties of cement, blast furnace slag and fly ash. So, what should be the fineness of slag? So, approximately fineness of slag, granulated slag is 500 centimeter square per gram if you measure with the bland surface area method, and that will not be so reactive. So, reaction is very important. So, if you consider the fineness of GGBFS, so that is approximately around 4000 centimeter square per gram by Bellini method. If you grind up to this one, you can get a good reaction property, and nowadays we are able to grind up to more than 6000 centimeter square per gram also, that is ultra fine GGBF. So, color is whitish, so that I have already discussed. So, this you can use just like a white cement. So, the color you can blend with the white cement also, because color of GGBF is almost white. And if you consider the fly ash, so that is just like a cement, and silica fume is more darker. So, this is the properties of GGBF, granulated grounded blast furnace slag. If you see the physical properties, this one I have taken from the Tata. These people are also supplying GGBS, and they will do the regular routine check as per the IS 16714/2018. This is the latest code, and if you see the ultra fine, this is for GGBFS, normal GGBF, whose fineness is around 4000. So, this is giving the so this is code IS 16714. If you consider the ultra fine GGBS, so that code is IS 16715/2018. So, so this code will go on the requirement of ultra fine GGBFS. Okay. So, these people Tata Steel from Jamshedpur, if you see here, they will go for all the testing, they will give you the test certificate also. So, what is their component? If you see the SiO2 is 32% and minimum and maximum is 38. Similarly, FeO component, COO component 32 to 38. So, like this Al2O3 component is also 16 to 22, sulfur component is 0.1 to 1.2, MgO is 6 to 11%. So, if they have done all this testing as per IS requirements of 1614, and they have also tested sampling procedure, they have adopted IS 1087. So, sampling procedure and testing method is also mentioned in IS 1208. 891987. So, this code also you can refer, because referring codal provisions is very very important, and if you want to understand the concrete technology. Okay. So, lots of codal provisions are there, because that is directly related to the field concrete technology, and it is not a mechanics. So, all the procedure you must follow this codal provisions. Okay. So, what are the things which is going to affect the reactivity of GGBS, granulated grounded blast furnace slag? So, first is a specific surface area. So, a specific surface area is very very important. Okay. So, if your specific surface area should be if it is around 4000 centimeter square per gram, then we will be able to achieve better results. So, which you have seen in the this commercially supplied GGBS in grounded form. It is supplied in grounded form by Tata, and some other many people are supplying this. So, you can see here they give the guarantee that their finesse is in the range of 4000 to 4200 centimeter square per gram. Okay. Then particle size distribution, this is also very very important. Okay. And mineralogy. So, mineralogy, we are not going to discuss mineralogy, because that is a very very complicated. So, it is not like clinker that we have only 4 combined C3S, C2S, C3A and C4AF. Here more compound is there, and characteristic of all the minerals is not very clearly known. So, still more research is required, but still mineralogy is important, and more or less we have to follow that code IS 16714. So, this should be, this component element should be within that limit. Okay. So, this is important. So, what is the advantages? What is the advantages of using GGBFS? So, we have lots of advantage. So, you will get the increase in workability, you will get increase in workability. Although the particle size is angular in nature, if you see the microscopic study, if you do for the GGBFS, so their size is very fine, but that is not going to affect, even it is angular in nature. And if you see the particle shape of GGB this fly ash, that is spherical in nature. So, that gives better workability with respect to GGBFS, but still here also you get improved workability. Then this is giving you decrease in water demands. So, water cement ratio, if you consider the water requirement, so water requirement is reducing here. So, you will get water cement ratio will reduce here for the given same workability. Okay. So, water demand is reduced. So, once water demand is reducing, so due to reduced water demand, what will happen? You will get improved strength, because water cement ratio requirement is this. This is your strength and this is your water cement ratio. This is your water cement ratio, if you see this curvature. Okay. So, you get better strength. So, decrease in bleeding, if your grinding is not better, if it is less than 4000, then you will not get better result in bleeding. But if you think that your concrete is going to bleed, in that case what you have to do? You go for more grinding, say around 5000, 6000 centimeters square per gram. So, that is able to control the bleeding of the concrete. Here also you will get increase in setting time. So, because here reaction is slow, because here whatever the product you are getting is calcium hydroxide. If you take the cement, say we have a C3S or C2S. So, this is going to react with water. and this is going to react with water, and that is going to make CSH gel plus calcium hydroxide. So, this is the simple reaction of your cement clinker. Okay. So, this calcium hydroxide is going to react, this is going to react with silica and silicate and aluminate part of the GGBFS, and that is going to produce you the final result here. Okay. So, the reaction is slow. So, as the reaction is slow, so heat of hydration is also less, and another things, if the reaction is slow, so whenever you are going for the hot weather concreting, you will not be getting the cold joint. So, cold joint problem can be eliminated if you are using the GGBFS. You can replace up to 70%. So, that is important thing, and it is reduction in heat of hydration. So, this type of cement is more suitable, GGBF is more suitable for mass concreting. Okay. So, this is, and if you see here, improved long term compressive strength. So, gain in compressive strength, if you consider the 28 days compressive strength, and if you check for more time, what will happen? Their strength will be improving. That graph I will show you after this brief explanation of this compressive strength, how it is changing here. And improved pore refinement. So, refinement is more better refinement you can get. If you consider this GGBF, so permeability of this type of concrete, if mortar is there, if you see the cement paste, okay, we have a cement paste, then from cement paste we can get the mortar and from there we can get the concrete. So, cement paste will consist of what? Paste. Paste will be nothing but that will be cement plus GGBF plus water, and that is going to give you the refined pores. Okay. Interconnected voids will be less, capillary pores will be smaller, and due to that mortar you can get the better mortar. And if you see the ITZ here, ITZ here transition zone, that also you are getting the improved transition zone where water cement ratio is less with respect to the normal concrete. So, due to that what you are getting? You are getting a decreased permeability. So, permeability of, if you are using this granulated grounded blast furnace slag, then you will be finding that permeability of that concrete is less, with much more less with respect to the normal concrete. So, since permeability is less and there is a increased resistance against the sulphate attack. Okay. So, this if you are using the GGBFS, so sulphate attack will be lesser, means expansal intrazide formation will be lesser. Another important benefit you can get, you will get the more resistance against alkali aggregate reaction. If your aggregate is having which is having a reactive silica is present in the aggregate. So, in that case if you are using the GFF, that reaction will be very slow. So, this is the advantage of using the GGBFS. But another disadvantage is also here. What is the disadvantage? If you have to do the cold weather concreting, rate of reaction is slow and heat of hydration is slow. So, in that case this may not be very much suitable, where we have to go for the cold weather concreting. So, these are the advantage, and this I will be discussing little more thing here. So, if you see here, here you see here. So, this is the unit water content. This is a concrete mix for slump of 120 mm. So, here 50 water cement ratio they have considered 0.5, water plus cement plus BFS water cementitious ratio is sorry, it is 0.5 water cementitious ratio. So, for this particular things, if you see, they have taken the two cells, one is at 20 degrees centigrade, another at 30 degrees centigrade. So, what you are finding here, demand for the water requirement is reducing. So, here replacement is 30%, 50% and 70%. So, here if you can observe here, even if you take the reference of this is a 160 and if you are replaced with 70. So, you will get a reduction of 10 kg less water. Okay. So, if water is less, then amount of cement requirement will reduce, So, if the requirement of cement is reducing, so another environmental benefit you are achieving, economy you are achieving, because a waste product you are utilizing here as a best product. Okay. So, if you see the reduced heat of hydration here, this diagram has been taken from the Portland Cement Association here. So, here is the 70% slag and they have taken ASTM type 1 cement. So, here you can find heat of hydration, say here 5 days, 10 days, 15 days, 20 days, 25 days. So, all the time you are finding that heat of hydration is much more lower with respect to the type 1 cement. Okay. So, this graph is clearly showing that we are getting a reduced heat of hydration. This is the research project. Okay. Similarly, if you consider the strength of blended cement containing a blast furnace slag, this the graph had been taken from the paper by Mehta PK. So, here they have taken no slag. So, normal cement is there where you have not put the slag, 40% replacement of slag, 50% replacement by slag and 65% replacement of the slag. If you see the compressive strength even at the age of 100 days here, initially you are getting a lesser strength, but as the time passes, if you see the 1 year compressive strength, there is a 100 days compressive strength, there is a drastic change here. You can see here this value is around 45 and this has increased to around 70. So, around 45 to 70 or so almost you can get this is the enhancement in compressive strength due to the use of granulated grounded blast furnace slag. So, this is very important. Okay. So, I will discuss briefly about the metakaolin. Metakaolin, if you see the metakaolin is a calcined clay and their color is also what is in nature. So, this metakaolin is produced by low temperature calcination of kaolin clay. So, you have to take the kaolin clay and you have to go with the low temperature. So, you have to work for up to the temperature of 650 to 800 degrees centigrade. So, what you have to do? So, clay is purified by water processing prior to the very carefully controlled thermal activation at a relatively low temperature, that will start low temperature of 650 degrees centigrade to 800 degrees centigrade. So, metakaolin is used where very low permeability is required or very high strength concrete is required to be produced. So, typical additions of around 10% by weight of metakaolin you can achieve the better result. So, metakaolin minerals also can be used as a additives. So, that way I have covered different type of mineral admixture. So, in 4 lectures duration of around half an hour I have covered different type of mineral admixture. And next class we will be discussing the chemical admixture. Thank you.